In 4.5 day 1, this is our example for the graph of the basic cosecant function, y equals cosecant of x. Now, in the previous video, I explained that cosecant is undefined when sine is equal to 0. Those graphs are related. So what we're going to do in this particular process is we are going to sketch sine to use as a sketching aid for cosecant. It's going to get a little bit messy, but we'll do it this way to just develop the idea of what this looks like. So here's how we're going to do it. We're going to start by sketching just plain old sine. Now we know sine has a period of 2 pi. That's going to go with cosecant, and so you can also count on the fact that cosecant is going to have a period of 2 pi. Now with sine, if it's unmodified, we just have an amplitude of 1, so we'll go up to 1 on top, we'll go down to -1 on the bottom, and sine starts at 0. Now the important points that we have, we separate a period out into 4 equal chunks, which I've already done, so each of these tick marks is going to indicate an important spot in this one. So we start our pattern, the sine goes up first, then back down to 0, then down, and then back to where it started, and we repeat the pattern over on the other side. Now, one thing to be careful about when we're doing these graphs is that we are graphing cosecant. We are not graphing sine. So if I'm going to put this in as a sketching aid, what I'm going to do is I'm going to make dotted lines. Remember that with dotted lines on a graph, they're not actually part of a graph. They're just sketching aids. But it's a good idea to have that on there. So I'm going to sketch my sine graph in as a dotted line. It must be dotted. If it's solid, then it says that that's a part of the graph, and we don't want that. All right, so there's my sine graph. Now, the important part about the sine graph is what we talked about in the last video, and that is where sine is equal to 0, that's where cosecant is undefined. Now, if something's undefined on a graph, that means that it goes to a vertical asymptote. So here's what it overall looks like. Wherever sine is equal to 0, in other words, wherever we have a 0 where it crosses the x-axis, that's going to be a vertical asymptote for our cosecant graph. So I'm going to have a bunch of these vertical asymptotes, these dotted lines, maybe one right on the axis as well. And I'm just going to put all of these in here as carefully as I can. These are my sketching aids, remember, and again, dotted lines show that it's not actually a part of the graph, but they give you some guidelines as far as how to graph this one. So we've done a lot of work already, and we really haven't even graphed the thing that we're trying to graph. So now let's actually put the cosecant on there. So the cosecant part, I'll put that in blue so it's really easy to tell. But one thing that you can be sure of when you're doing these is that one point you'll always have is point at the top and the bottom of these branches on the sine graph. So the reason for that, we know that at pi over 2, sine is equal to 1. Now, cosecant is the reciprocal of sine, so if we have the reciprocal of 1, that's still 1. And if we have the reciprocal of -1, that's still -1. So all of those points at the peaks are points that we use in our cosecant graph. Next up, though, is I want to get a couple other points to help describe this. And once we do, we're then going to kind of extrapolate and just repeat the pattern for the rest of it. So we're most of the way through this problem. But here's what we need to do is I think we need to choose a point, the easiest point possible, that's somewhere in between the middle here and between the side, in between that vertical asymptote. So on all of these graphs, here's what I'm going to suggest. We take a look at this little chunk that's right next to the axis, the closest one we can find, and then we choose the point halfway in between. Now, what is this point even? Well, if we follow the labeling here, we've got pi. This is pi over 2, and so then this one in here turns out to be pi over 4. Here is a guarantee for you if you're doing these graphs the same way that I'm doing them, is that somehow, some way, it's always going to get back to pi over 4 if you're selecting your points in the same way that I am. So I've got pi over 4 here. Now, what do I do with that pi over 4 to get the other point? Well, I'm going to plug it in to the cosecant graph. So I've got to think about what is the cosecant at that point. I'm just going to plug it in here. So cosecant of pi over 4. Okay, what is that equal to? Now, as we've become accustomed to, I hope, we're maybe doing some triangles for this. So we know that pi over 4 is the triangle in the first quadrant. It's our 45, 45, 90. So you can think of it as 45, but that has sides of square root of 2 over 2, square root of 2 over 2, and 1. So if we want to get the cosecant, which is the hypotenuse over the opposite, it's going to be 1 over square root of 2 over 2. Now that's not simplified. We need to get it a little bit better than that. And to get it a little bit better than that, one thing is we can, well, it's just the reciprocal of this one. So you can think about dividing by a fraction, the same thing as multiplying by its reciprocal. So that's like saying 1 times 2 over square root of 2. Well, and then we know anything times 1 is just itself, so that's the same thing as 2 over square root of 2. Now we need to simplify it and get rid of this root in the denominator, and so we're going to take square root of 2 multiplied by square root of 2 over square root of 2. Then it gives us, almost there, 2 square root of 2 over 2, and those 2's can cancel, so we're left with a much simpler version, which is just square root of 2. So what that means is that this is going to give us a point. It's going to be pi over 4 as the x value and square root of 2 as the y value. Square root of 2, if you're to plug that into your calculator, is about 1.4. That's as close as we're really going to need it here. So I'm going to add a little bit of space to my graph. I'm going to go up one more here. I'm going to go down one more here. And I want to do pi over 4, 1.4, or square root of 2. I'm going to put that so it's about right there is my point. Now, the nice thing is that there's symmetry on the rest of these graphs, and the symmetry is going to mean that if I go in between right here, this point is going to be symmetric to that point. It's also going to be at pi at 1.4, square root of 2, approximately right there. And then I'm going to connect the dots and make this one branch in here. All right, so that one branch is going to be representative of all the other branches throughout my graph. So now I can go and just sort of eyeball it. I'm going to just do the best I can here. I'm not going to be too concerned about getting exactly on, but I'm just going to mimic the shape in all of those different branches. And we're going to do that for the 2 full periods that we have set out. So we've got that, and then we've got one more about right there and about right there. And we've got a pretty good looking graph of cosecant. Now I do want to mention here that the period is 2 pi. You might be inclined to think that this represents 4 full periods, but it really doesn't. It represents 2 full periods of this graph. The full period is from where the sine starts to where the sine ends. So 1 full period of cosecant is 1 branch up and 1 branch down. So this gives us a total of 2 full periods in this case. There is only one other thing I'd like you to do in this problem, and that is to label the point that we found at the beginning. This point that we got right here, we chose as pi over 4 for the x value, and that returned square root of 2 as the y value. I would like you to also include that point so that I know you're doing this by hand, and that just shows me a little bit more information. So it's a mess, but we've got everything. This is the process for doing a cosecant graph. If you want a little bit more of this, the secant graph in the next video will give you more of stuff that's very similar to this.